Well, hello and welcome to this the second in my series on an introduction to position vector and displacement vector. Now, this is all we are given. We will be asked to complete this table, and that's it, nothing else. So, and what I've done is to, as usual, to create a grid to help me explain what I'm doing here. And this is the grade, and at point 00 or 00 we got O, the control tower, as it were, is located at 00. Now the town A has got a position vector of 2 units to the right and 6 units up, as 2, 6 as given to us there. Now the displacement from A to B is 3 units to the right and 2 units down. Right, now I've got a little triangle here that ties in displacement and position vector at the start and the position vector of the aircraft at the finish. Alright, so there's a little algebra here which says that D, with displacement, is equal to minus the position vector at the start plus the position vector at the finish. Now that's a simple algebra here. You can change this to make any of these the subject of whatever you require. So that's the displacement, and we know that's 3 minus 2. Okay. We require to find the position vector at the finish, so we want to find PF. So if you make PF the subject, now PF is equal to the displacement plus the position vector at the start. Okay, so now we add 2, 6, and we add 3 plus 2 give us 5, and minus 2 plus 6 give us 4, so we end up with 5, 4. Now, if you think about it, we're going from O to B. Okay, just assuming that we don't have this grid here, we don't know what O to B is, but we know what O to A is there, and we know what A to B is. So to go from O to B, we go from O to A and then A to B, so we're there. Right, so finally, and that's what we require to fill in for this gap here, and I hope that makes sense. Now for the next slide, which is that one there. Now we want to fill in this gap here, this one here. All right, we know the position vector, we know the position vector at the finish and at the start. We want to find the displacement from A to C, so we want to find this from A to C. So we're going to go back on ourselves here and then up there as it got there. Right, so now we've got we're going to go back ourselves, hence the minus sign, minus 2, 6, so minus 2 and minus 6, and then you add P sub F there, and that's what we got. Okay, we know that P sub F given to us is 8, 6. Now 8 minus 2 is 6, and 6 minus 6 is 0, so we end up with 6, 0. So the aircraft will fly horizontally for 6 units. Okay, and that's what we got there. So, and that's 6, 6 there, and that's O to A, and that's O to C, also control tower to town C. That's the position between towns A and town C, and that's 6, 0. Right, now for this slide, we're trying to fill in this gap here. We want to find the P sub S for B when the aircraft is at town B. Now, if we're right, because B has not moved, that figure there should be the same as this one here when we flew from town A to town B. All right, okay, now let's check. Now, because we're looking for P sub S there, looking at the algebra, if P sub S goes across to the left hand side, the sign will change. And then D goes across to the right hand side, the sign will also change. So we end up with P sub S as equal to P sub F minus D. So now P sub F we know as 86, and that's given to us there. And because we're going to subtract the displacement to do minus, okay, and that's indeed P sub F. Now when we subtract the displacement 3, 2, we end up with 8 minus 3 is 5, and 6 minus 2 is 4. So now PS during our flight from B to C, at the start of the flight from B to C, the position vector of the aircraft reference to the control tower is 5, 4, and that's what we got there. And if we check, that's 1, 2, 3, 4, 5, 1, 2, 3, 4, and that's correct. And that's a figure there, and that is the same as that one there. Okay, so those should agree there, so that's fine, we're okay. Now for this one here, we are trying to find to fill in this gap here. Okay, so we want to find the position vector at the finish of the flight from town B to town D. So you know, we want to find the position vector of town D. Okay, so that's PF. Now from our little algebra here, if we want to make PF the subject, then PF is equal to D plus P sub S. Okay, so that is the displacement from town B to town D, which is 5 to the right and 5 units up. Okay, and that's what we got there. We got 5 to the right and 5 up there. So now we add the position vector of the aircraft as reference from the control tower, and that's 5, 4, and that's PS, P sub S. Right, and that is P sub S as we see here, and that's 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's the position vector of town B, that's P sub S. Now we want to find P sub F, which is from O to D. Go there and add up there. So we add those up and we get 5 plus 5 is 10, and 5 plus 4 is 9. And if we then put that in our grade, we can see that OD, that's P sub F, is 10, 9. And we enter our figures in there. I hope all that made some sense. Please subscribe, and thank you for watching. See you again sometime. Bye bye.